Welcome to the world of swarm robotics. Imagine lots of tiny robots, all working together as a team to do big jobs. These aren't like one giant, super smart robot. Instead, it's a whole bunch of smaller, simpler robots. Each one might not be a genius on its own, but together, they can achieve incredible things. Think about it like this. One single ant can't build an entire anthill, but a whole colony of ants, each following simple rules and communicating in basic ways, can construct massive, complex underground cities. Swarm robots operate on a similar principle. Each little robot in the swarm has a set of simple instructions. It doesn't need to understand the entire big picture. It just needs to know what to do based on its immediate surroundings and the actions of its nearby robot buddies. This approach is very different from how we usually think about robots. Scientists and engineers look at how creatures like ants, bees, fish, and birds coordinate their actions. These animals achieve complex group behaviors without a central leader telling everyone what to do. Instead, they rely on local interactions. Nature is truly the best inventor, especially when it comes to teamwork. Just look at an ant colony. A single ant might seem pretty basic. It doesn't have a giant brain or super strength, but when you get thousands or even millions of ants working together, they become a superorganism. They can build incredible structures like massive mounds with complicated tunnels and chambers. They can create living bridges out of their own bodies to cross gaps. They efficiently find and transport food back to their nest, all through cooperation. Bees are another amazing example of nature's swarm intelligence. Think about a beehive. It's a bustling city of activity, all perfectly organized. Bees work together to build intricate honeycombs with perfect hexagonal cells. They assign different jobs within the hive, like nursing the young, cleaning, guarding, and foraging for food. When a forager bee finds a great patch of flowers, it returns to the hive and performs a special waggle dance. This dance tells other bees the direction and distance to the food source. Isn't that an incredible way to share information and coordinate a massive workforce? So, if these swarm robots don't have a central leader, how do they actually coordinate their actions and work as a team? It all comes down to communication and local interactions. They don't usually have complex conversations like humans do. Instead, their communication is often very simple and direct. This simplicity is actually a strength because it makes the system more robust and easier to manage. Each robot only needs to pay attention to its immediate neighbors and its local environment, which simplifies things a lot. One common way for swarm robots to talk is through signals. This could be as basic as flashing an LED light in a specific pattern. Another robot nearby might see this light and understand it as a cue. Maybe it means I found something interesting, or danger, move away. Some robots use infrared sensors to detect each other or to send simple messages. Others might use short-range radio signals, like tiny invisible walkie-talkies, allowing them to exchange small bits of data. The key is that the communication is usually local, meaning robots only interact with those close by. This idea of local interaction is super important. A robot in the swarm doesn't need to know what every other robot is doing across the entire area. It just needs to react to what's happening right around it. The real magic of swarm robotics lies in how complex group behaviors can emerge from very simple individual rules. Each little robot in the swarm isn't programmed with a grand plan of the entire mission. Instead, it operates based on a handful of straightforward instructions. Think of these instructions like the basic rules of a game. For example, a robot might be programmed with a rule like, move forward until you sense an object. Or another rule could be, if you detect a signal from another robot, turn towards it. These rules are easy for each robot to follow. Let's imagine a few more simple rules. A robot might be told, if you are carrying an item and you find the designated drop-off zone, release the item. Another rule could be, if you haven't sensed another robot for a certain amount of time, start exploring in a spiral pattern to find one. Or, if the light intensity is above a certain level, move towards the darkest area. These individual rules don't seem very sophisticated on their own. A single robot following these rules might just wander around a bit or perform a very basic action. Swarm robotics isn't just something we dream about for the future. It's already making a difference in the world today. Researchers and companies are finding all sorts of practical ways to use these tiny, cooperative robot teams. One of the most talked about applications is in search and rescue operations. Imagine a building has collapsed after an earthquake. It's incredibly dangerous for human rescuers to go inside. A swarm of small, agile robots could be deployed to navigate through the rubble, search for survivors, and send back information about conditions inside. Another area where swarm robots are proving useful is in logistics and warehouse automation. Big warehouses are incredibly busy places, with thousands of items needing to be sorted, moved, and shipped. Swarms of small, autonomous mobile robots can zip around the warehouse floor. They can pick up shelves of products and bring them to human workers for packing, or they can sort packages onto different conveyor belts. This makes warehouses much more efficient and can speed up the delivery of goods. It's like having a super organized team of tiny helpers working around the clock. Environmental monitoring is another exciting field for swarm robotics. Using a swarm of many small robots instead of one large complex robot offers some really significant advantages, especially for certain types of tasks. One of the biggest plus points is something called robustness. Now, what does that mean? Robustness means that the system can continue to function even if some parts of it fail. In a swarm, if a few individual robots break down or get lost, it's not usually a catastrophic failure for the entire mission. The remaining robots can often adapt and continue the work, perhaps a bit slower, but the job still gets done. This is a huge benefit compared to relying on a single, highly sophisticated robot. If that one big robot fails, the entire mission might be over. But a swarm is much more resilient. Think of it like a sports team. If one player gets tired or injured, the rest of the team can often adjust their strategy and keep playing effectively. This fault tolerance makes swarms particularly well suited for tasks in dangerous or remote environments where repairs might be difficult or impossible. It adds a layer of safety and reliability that is hard to achieve otherwise. Another fantastic advantage of swarm robotics is scalability. While the idea of swarm robotics is incredibly exciting and full of potential, there are definitely some big challenges that scientists and engineers are working hard to overcome. It's not as simple as just building a bunch of tiny robots and letting them loose. One of the major hurdles is the complexity of programming and controlling a large group of autonomous agents. Designing those simple individual rules that lead to the desired complex group behavior is a really tricky task. It often requires a lot of simulation, testing, and tweaking to get it just right. Another significant challenge is power. Each little robot in the swarm needs its own power source, which is usually a battery. For small robots, batteries are also small, and they don't last forever. If a swarm is deployed for a long mission, keeping all the robots powered up becomes a big issue. Researchers are exploring various solutions, like developing more energy-efficient robots, creating ways for robots to autonomously dock and recharge themselves, or even harvesting energy from their environment, like using tiny solar panels. But ensuring long-lasting operation for a large swarm is still a tough nut to crack. The field of swarm robotics is buzzing with innovation, and the near future promises some truly amazing advancements. Scientists are constantly pushing the boundaries of what these tiny robot teams can do. One exciting area is making swarms even smarter and more adaptable. This involves incorporating elements of machine learning and artificial intelligence. Imagine robots that can learn from their experiences during a mission. If they encounter a new obstacle or a surprising situation, they could figure out the best way to respond without needing a human to reprogram them. This would make swarms much more autonomous and versatile. We are also likely to see more heterogeneous swarms. What does that mean? It means swarms made up of different types of robots, each with its own special skills or tools. For example, you might have some robots in the swarm that are really good at sensing the environment. Maybe they have advanced cameras or chemical sensors. Other robots in the same swarm might be specialized for carrying objects, or for digging, or for communication over longer distances. The long-term possibilities for swarm robotics are mind-blowing. It's like peering into a science fiction movie, but these are real concepts. These tiny cooperative robots could reshape our world. From medicine to space exploration, swarm robotics holds promise. Tiny technology making a giant difference. Nanobots could revolutionize medicine. Imagine robots traveling through our bloodstream. They could target and destroy cancer cells, repair cells, deliver drugs, or clear blockages, transforming healthcare with targeted medicine. Then there's space exploration. Building structures on the Moon or Mars, swarms of robots could handle these tasks, construct habitats, mine resources, or deploy instruments, ideal for long missions in harsh environments.